Hello everyone, Assalamu alaikum. My name is SM Abidujjaman and we have made a circuit for 4-bit asynchronous up counter using JK flip-flop. So let's see what is asynchronous counter used for. Asynchronous counter mainly used for the time delay output. It means the asynchronous counter provides output after some time delay. Okay, there are different types of asynchronous counter. One is up counter, one is down counter, one is up down counter. So we have implemented the up counter. So let's see the components. We have used breadboard resistance, we have used 270k resistance, also 270 ohm resistance, then capacitors, 100 microfarad capacitor, then some LEDs. After that 7473 IC, which is JK flip-flop. We have used 2 JK flip-flops, then some connecting wires, and then LM556 timer, and lastly 9-volt battery or adapter. Let's see the circuit diagram. Here is our circuit diagram. So this is JK flip-flop, then J and K is shorted and connected to VDD, which is high input. Then the clock is coming from here, and in the second JK flip-flop we have connected the clock from the output of the first JK flip-flop, and then JK is again shorted and connected to high VDD. So thus the circuit is implemented. You can see the repetition of this output to clock, then again output to clock, and JK is shorted and connected to VDD. So this is the circuit diagram. So we have to understand what is the benefit of making a 4-bit asynchronous up counter. A 4-bit asynchronous up counter can be used for making digital clocks. So if you want to make a digital clock, you can use a 4-bit asynchronous up counter. So this is a very basic use or a common use of 4-bit asynchronous up counter. So let's see the cost estimation or cost analysis. So the breadboard may cost 130 taka. The resistance is 30 taka. Then the capacitor is 40 taka. And LED, we have used some LEDs, 4 LEDs in total. So that will cost you around 20 to 25 taka. And JK flip-flop will cost you 45 or 50 taka. Then connecting wires, it depends how much you buy. So we have buy a bundle. So a bundle will cost you 20 to 30 taka. Then LM556 is 40 taka or 50 taka. Then 9-volt battery may cost you 70 or 80. And last but not the least, battery clip will cost you 30 taka. So the total cost is 430 taka, which is quite reasonable. And if you see the digital clocks, the price of digital clocks in market, they will cost you around 500, the low qualities, and if you want to buy high quality, so it will cost you around 1000 to 1500 taka. So it is quite efficient. So let's see the references. We have used references as electropage.com. You can find this circuit diagram from electropage.com, and also the components, also the types and meaning of asynchronous counter. So I will show you how it works. So let's see how the circuit works. Thank you. Now I am going to show you how the circuit works. Here we have used 100 microfarad capacitor. This is 250k resistor. This is 250 ohm resistor. This is our LM556 timer, and these two are IC7476, which is flip-flops. So, and here we have used 1k resistor for output. These are the LEDs. So we have connected the 4 number pin, which is VCC of 7476, to the positive and 11 number pin to the negative, and then the output is going to this flip-flop clock, and again the output is going to the LED. So, and the timer is connected using 7 point, which is ground, and 14, which is VCC, and phone number is output, so it is connected to ground and positive. So now Ferdous will explain the output of the circuit.
Hello, I am Ferdous Mohammad Omar Hussain, and I am going to uh, describe the output. Let's show how it works. Firstly, we have to connect the circuit with the battery, and we done the negative port, and here it is shown that here we can see that it is delivering 0 to 50 binary code. For better view, you have to put the circuit in a dark place, and thus it will show you 0 to 50 binary bit